Okay, looking at the next set of conjectures, we're first going to start with conjecture number 9, which is the angle bisector concurrency conjecture. All this one is saying is that if you construct the 3 angle bisectors of a triangle, that those meet at a point. That point is called the point of concurrency, and these 3 lines are concurrent. Same idea here with conjecture number 10, the perpendicular bisector concurrency conjecture. If you construct the 3 perpendicular bisectors of the sides of a triangle, those 3 bisectors will always meet at a point, no matter how the triangle is moved. Conjecture number 11, the altitude concurrency conjecture, also states that those 3 will always meet at a point, no matter how the triangle is moved here. So those will always meet at one point. Conjecture number 12, the circumcenter conjecture. If you construct the 3 perpendicular bisectors of each side of a triangle, and you measure the distance from that point to the vertex of the triangle, you will see that it is equidistant to each vertex. So no matter how the triangle moves, that point is always the center of the circle that circumscribes the triangle. Again, this point, the circumcenter, is equidistant to each side, each vertex of the triangle. Conjecture number 13, the in-center conjecture. What this states is that the in-center, the point of concurrency of the 3 angle bisectors of a triangle, is equidistant to the sides of the triangle. So what I need to do is I need to measure a direct path from the point directly to the side. To do that, I need to construct a perpendicular. So select the white, or click on the white part of the sketch to deselect everything. Click on the in-center and one side. Construct perpendicular line. And then what we'll do is we'll just make a segment that goes from the in-center directly to the side line. Okay. If you grab your marker tool and you drag into the angle, you can see that this is a right angle. Okay. If you right click on the line, you can hide it. Let's just go ahead and hide all of these. Right click and hide, right click and hide, right click and hide. So here's my in-center. I've now created a pathway directly to the side length. So if I take my circle tool and I go from the in-center directly to the side, you can see that it is equidistant to all 3 sides of the triangle. Okay. So no matter how the triangle is moved, that point remains equidistant from the 3 sides.